Welcome. In this video, I'm going to walk you through how to find the equation of a plane containing 3 points. So we're given these 3 points here, P, Q, and R. The first thing you want to do is find 2 vectors in the plane. And you can do so with any 2 points you want. I decided to go with P and Q first. So PQ, we start with the x-coordinate of Q, so that's 3 minus the x-coordinate of P, which is 1. Do the same thing for y, so this is 1 minus negative 2. And then we have 4 minus 0. So this will give us 2, 3, 4. Now do this again for another 2 points. I chose PR. And the resulting vector here is negative 1, 1, 2. Okay, so the next thing you want to do is find a vector normal to this plane, and you can do that by taking the cross product of these 2 vectors. So here's 1, and here's 2. So our normal vector is going to equal the cross product of PQ with PR. We can find that using this matrix IJK. And this will work out to be I times 6 minus 4 minus j times 4 plus 4 plus k times 2 plus 3. So you end up with 2i minus 8j plus 5k. So our normal vector is simply 2, negative 8, negative 8, 5. Now we just want to find the equation of the plane. All right, and to do that, let's suppose let point M be point X, Y, Z, and this is an arbitrary point in the plane PQR. Then I'm going to use, say, and I can use any point I want. To make things easier, I'm going to use a point with a 0 in it, so I can use P or R. I'll use R. So let's look at the vector connecting R and M. So this vector is going to be X, comma, Y plus 1, comma, 2 minus, not 2 minus Z, Z minus 2. And our plane is going to be the product of N with vector QM. So this is the dot product here. So I have 2, 8, negative 8, 5 with x, y plus 1, z minus 2. And I want to stress I could have used any other point here. I didn't have to use r. And we end up with 2x minus 8y minus 8 plus 5z minus 10 equals 0. So this is 2x minus 8y plus 5z equals 18. So this is the equation of our plane containing these 3 points. All right, so now we're going to use intercepts to sketch the plane that we've already found. And I'm going to add one more thing. We're going to use intercepts and technology. Okay, please visit geogebra.org, go to Classic, and then, of course, go to 3D Graphics. And you will not have this pop-up come up. I just tend to have a lot of GeoGebra tabs and windows open. So once you are in 3D Graphics, let's plot 3 intercepts. So let's start with the x-intercept. And remember, just to make it a little clearer, I'm going to hide the plane. And I'm going to rotate this a bit. There we go. So this is the standard way you'll see the 3-dimensional plane in a book. Here's your x-axis, your y-axis, and your z-axis. So these are color-coded. X is red, y is green, z is blue. Okay, so now let's consider the x-intercept. So let's start there. The x-intercept occurs when y and z are both 0. So 2x equals 18, or x equals 9. And in GeoGebra, that's the point 9, 0, 0. which is out there, beyond what we can see. So I'm going to go ahead and click Move Graphics View, and you have to hold this right over the x-axis, the red axis. You don't want to see 4 points, you want to see 2, and then go ahead, there we go, just kind of pull that in towards the origin. And then rather than calling this A, I'm going to go here. I'm going to, let's say, rename this. Actually, I don't want to rename this. And you'll see why in a second. I'd rather use a caption. So I'm going to right click and go settings. And you know what? You might like to rename them. It's a preference. I don't. I'm going to write in x-intercept. There we go. All right. And then you can go ahead and move that here. So there's our x-intercept. Now let's go back and look at the y-intercept. So the y-intercept, this occurs when x equals z equals 0. So we have negative 8y equals 18. So y equals 18 over 4, excuse me, over 4. I'm doing arithmetic in my head and I'm doing it incorrectly. Negative 18 over 8, which is negative 9 over 4. Okay, so back in GeoGebra, I can make the next point 0, comma, negative 9 divided by 4. Then you need a right arrow. If you just click a comma, you'll have 4 comma in the denominator, which won't work. So right arrow, comma, and then 0. And there is my y-intercept. And so I'm going to do the same thing where I'm going to right click it, go to settings, and type in y-intercept. And then hit the X to close the settings. And of course, I'm going to move it around as always, so it's easier to see. There we are. Now, let's go ahead and look at the z-intercept. So the z-intercept, we have x equals y equals 0. So in this case, we have 5z equals 18, or z equals 18 over 5, and that's 3.6. So let's go ahead and back to GeoGebra, go 0, comma, 0. You can do 18 over 5 or 3.6. It'll be the same thing. There we go. And right click this. And my caption is z-intercept. I'll close that out. So the idea is you can sketch a plane between these three. Okay, so here is our sketch of the intercepts, and you could have easily done this by hand. Here's the x-axis, y-axis, z-axis, and plotted the 3 points. And the idea is you just want to connect the dots here. And so you can kind of see where this plane would begin. And of course, you imagine it going out in these directions indefinitely. But of course, that makes it a little too messy to see. So I'm just going to leave it here. It is not a triangle, it is a plane that would continue. And of course, with technology, we can do that as well. So you can click on the plane through 3 points, and you can select it, and then click X, Y, and the Z-intercept, and that gives you your plane. Alternatively, I'm going to click undo real fast. You can also type in plane A, comma, B, comma, C. And there is your plane. And it is a bit easier to see like this. There we are. Our plane through X, Y, and Z. All right, and here are two different perspectives. This is mostly hand-drawn, this plane here, and this is completely using technology. You can see here's the spot that I marked manually on the other sketch, just connecting the 3 intercepts. I hope you found this video helpful.